Ever wondered what a tiny blade of grass and a massive blue whale have in common? Well, they both run on the same power source, and they follow a really simple but powerful set of rules. Today, we're going to uncover exactly how that energy moves through every single ecosystem on Earth. It's an incredible journey that connects all of us.
So, let's start with a little riddle. A tree, a lion, and a mushroom. I mean, on the surface, they couldn't be more different, right? But here's the thing. They are all essential players in the exact same game. And once you understand what connects them, you'll get a fundamental secret about how all life actually works.
I mean, we all know this, right? You get hungry, you eat some food, and suddenly you have energy to move, to think, to live. But if you trace that energy back, and then trace it back again and again, where does the whole journey actually begin? Where does the power for our entire living planet come from?
It all starts right here, 93 million miles away. That incredible, giant fusion reactor in the sky, our sun, is the ultimate power plant for almost all life on Earth. Everything begins with a little bit of sunlight. But how in the world does that sunlight become something a lion can use?
Well, that's where our first group comes in. I want you to think of them as the master chefs of the natural world. They're the only ones who can take that raw energy from the sun and, cook it into actual food.
The official name for these chefs is producers, and their special recipe? It's a little thing called photosynthesis, that kind of magical process where they use sunlight, water, and carbon dioxide to create their own food. We're talking about sugars, pure energy. They literally make food out of thin air and light.
And these guys are absolutely everywhere. It's the grass in your local park, the huge trees in a forest, and even the teeny tiny algae floating in the ocean that you can't even see. All of them are producers, just working away, capturing the sun's power for the rest of us.
And this is so important. Without producers, the whole energy journey would just stop. It wouldn't even begin. They are the foundation, the absolute first link in the chain that brings all that solar power down to Earth.
All right, so if the producers are the chefs, then that means every restaurant needs customers, right? These are all the living things that can't cook for themselves. So let's meet the energy takers. And we call these guys the consumers. So unlike producers, they can't just soak up the sun and make a meal. Nope. To get the energy they need to live, they've got to eat other living things. Now, we can break consumers down into three basic groups. First up, you've got your herbivores. These are the plant eaters, like cows and deer. Then you've got your carnivores, the meat eaters, like lions and tigers. And finally, there are the omnivores, who eat a bit of both, like bears and, well, us.
Yep. Think about it for a second. That sandwich or salad you had for lunch today, that makes you a consumer. You are an active part of this incredible planet-wide flow of energy. How cool is that?
Okay, so we've got the chefs and the customers. But what happens to all the leftovers? What about when plants and animals die? That's when the most important and honestly the most overlooked team in the entire ecosystem gets to work.
Say hello to the decomposers. These guys are nature's ultimate recyclers. They get all their energy by breaking down dead organic stuff, everything from a fallen leaf to the remains of the biggest animals.
And who's on this cleanup crew? Well, it's mostly fungi, like that mushroom from our big question at the beginning, and just billions and billions of bacteria. They're basically the planet's sanitation department.
But their job is so much bigger than just cleaning up. See, as they break things down, they release all these essential nutrients back into the soil. And those are the very nutrients that producers, like trees and grass, need to grow in the first place. They're the critical link that keeps the whole system from grinding to a halt. Okay, deep breath. We've met all the players, the producers, the consumers, and the decomposers. So now, let's put it all together and actually follow the energy as it moves between them.
The path is actually really clear and direct. Step 1, energy blasts out from the sun. Step 2, producers, our plant buddies, capture that solar energy. Step 3, consumers get that energy by munching on the producers or other consumers. It's a straight shot.
And this brings us to the two golden rules of energy flow. First, it's a one-way street. A lion can't give its energy back to the gazellidate. The energy only moves up. Second, and this is super important, a ton of energy is lost at every single step. In fact, only about 10% of the energy from one level makes it to the next. The other 90% is just lost as heat. It creates this pyramid, with way less energy available the higher up you go. And this shows us a really important difference. Energy flows through an ecosystem.
It's a one-way trip and then it's gone. But nutrients, they're different. Thanks to our friends the decomposers, nutrients get cycled. They travel in a continuous loop, constantly being broken down and then used all over again.
And with that, we can finally answer our big question from the start. What do a tree, a lion, and a mushroom have in common? Well, now we know. They are each a critical, irreplaceable link in the chain of life. The tree is a producer. It makes the energy. The lion is a consumer. It takes the energy. And the mushroom is a decomposer. It recycles the building blocks for the next generation.
They're just 3 different jobs in the same epic story, all connected by that constant, one-way journey of energy, from the sun, through all of life, and then back out into the universe. That simple flow is what powers every single living thing you've ever seen.
So this entire, incredibly complex system is built on a simple, one-way stream of power from a star millions of miles away, which kind of leaves us with a pretty heavy question, doesn't it? What happens if that flow is interrupted? What happens when just one of the links in this absolutely vital chain is broken?